Hey folks, we're going to do the Chapter 9 Carlton review, writing probability as a fraction, decimal, and percent. Got a marble jar here that's going to basically do you no good unless you can see black and white colors in color. But we do have it here, 7 red, 3 blue, and 10 green marbles. So it looks like we have a total of 20 marbles altogether. So the probability of drawing a red marble. Let's do it as a fraction first, because really that's where it all has to start. So a probability of a red would be 7 out of 20. The way you turn that into a decimal is you just take and divide it. 7 divided by 20. That's what the fraction bar means. And you got 0.35 is the decimal, 0.35. Let's take and move that 2 places to the right, and we have ourselves 35%. Again, remember, moving it 2 places to the right is multiplying by 100. Okay, the blue dudes. We've got 3 blues out of 20. You put that into your calculator. 3 divided by 20, and you should get 0.15. 0.15, which you're pretty confident is 15%. All right, and the green marbles. We've got 10 green marbles out of 20, 10 out of 20. So that is going to be 0.5 or 50%. All right, let's take a look at the cards we have down here below. We have 13 black clubs, 13 black spades, 13 red hearts, and 13 red diamonds. So we've got ourselves a standard deck of playing cards here, minus the jokers. So we should have 13 times 4, which is 52. All right, what's the probability of getting a club? Well, a probability of getting a club. Well, do this one more time. We'll take the 13 times 4. So there's our 52. So all of these cards together are 52. So I'm going to go over my fraction. We have 52 here. The clubs, there are 13 clubs. Now, it's going to be 1/4. You can probably already figure that out, but you can take 13, you can divide it by 52, and you will see that you get 0.25, or 1/4. And the probability, the percent, of course, then is 25%. Again, remember, just move that decimal 2 places to the right or multiply by 100. Probability of getting a 5, well, we still have 52 cards, but how many 5s are there? Well, they're right here. There's only 4 of those. So this is going to be a little bit different. So we have 4 divided by 52, which is going to be 0.0769. Doesn't say what to round to on here. So we're just going to go to the nearest, let's go to the nearest hundredth. So it is 0.0, I'll write down here, 0.076. If we're rounding to the nearest hundredth, we have to look behind that line there, behind the penny line as I call it. There is enough there to call that 0.08. Move that 2 places, 8%. What's that? Yeah, that is 1/13. All right. Turn the page. All right, I can find the probability of a complementary event. Write the complementary event of the following events. Write as a fraction in simplest form. Use information from number 1. Let's go back to our marbles here. See if we can get this on there so that's going to work. Barely. Barely we'll get her set. Okay, write the probability of the complementary event. Use information number 1. Probability of not getting a green. Well, if the probability of getting a green is 10 out of 20, the probability of not getting a green has got to be 10 out of 20. We have to put this in simplest form. This is, of course, 1/2. Probability of not getting a red marble. Well, the probability of getting a red marble was 7 out of 20. 7 out of the 20. So not getting a red marble, that's going to be 13 out of 20. That dude is in simplest form. You got a prime number on top. The denominator is not a multiple of 13. So very good. All right, now we're looking at the information from number 2. We've got our cards. I don't know if we're going to need that. I think we could probably figure this out. Okay, so now we're looking at the probability of not getting a club. Well, if you remember, the probability of getting a club from the standard deck of cards was 1/4. It's 13/50 seconds. We just reduce that to 1/4. So the probability of not getting a club is going to be 3/4. Because again, 3/4 plus 1/4 will equal 1/2. The probability of not getting a 5, well, the probability of getting a 5, I'll just jot it over here, was 4/50 seconds, or 1/13. So the probability of not getting a 5 is going to be 12/13, because 12/13 plus 1/13 would equal the 13/13, or 52/50 seconds. All right, I can find sample space. Let's move on to the next target here. All right, determine the sample space of the guy's closet. Show your sample space by making a tree diagram. So it looks like we've got a red shirt, green shirt, yellow shirt. We've got some pants, some shorts, and some sneakers. Well, this is an interesting closet. We've got 3 shirts, 2 things to wear on the bottom, or 3 tops, 2 bottoms, and then they're always going to wear the Nike shoe. So this one here, this one really is kind of like not applicable to this situation, because they're always going to wear the Nike shoes. If you really wanted to draw that on the end, you certainly could. But we've got a red shirt, a green shirt, and a yellow shirt they could start off with. And of course, they could wear either pants or shorts, pants or shorts, pants or shorts. And they will always be wearing the Nike shoes. So you could think of that over here as, you know, your Nikes. But here's your sample space. There's going to be a total here of 3 times 2, or 6 outfits. You could think of it a little bit differently if you were going to say you could go with shoes or without shoes, but we're just assuming they're always going to wear shoes on this one. All right, let's make sure we answer the question. Sort your sample space by making a tree diagram. We did that. Red, these are the shirts. These are the bottoms. And we've got the shoes that we'll wear with all of them. All right. Let's take a look at these ones. Using that same chart, what's the probability of wearing jeans? Well, if you take a look at our chart here, just slide that in. You could wear the red shirt with the pants or the jeans. You could wear the green shirt with the pants or jeans. You could wear the yellow shirt with the pants or jeans. So we've got 3 out of 6 here, or 1/2. Think about it as 50%. That's the probability. All right, here we're looking for a red shirt, jeans, and the Nikes. All right, well, they're always wearing the Nikes, so that's not really a factor. But you got the red shirt here and jeans. There's only one combination where they're wearing that red shirt and the jeans. So that's really 1 out of 6. That is in simplest form. You could think of that as 16.6% repeating, or you could round it to 16.7% if you wanted to come up with it, do it that way. All right, I can calculate the experimental probability. We've got this all set up here. Next target, this would be 9.7a. Using the table above, what is the experimental probability of getting a heads? Well, they flipped a total of 50 times, and they got 26 heads, so it was just a little bit over what our theoretical probability. So 26 divided by 50, and we'll just pop that in the old calculator. 26 divided by 50. We end up with 0.52. So 0.52, or 52%. If we wanted to put this as a fraction in simplest form, so we'll go ahead and reduce that down to 13/25. Using table above, what is the experimental probability of getting a tails? Well, if this is 13/25, the tails have to be 12/25 because that's the complementary event. You can go ahead and figure that out. That's going to be 0.48 if you like decimals and 48%. Wait, what? You don't trust me? All right. 12 divided by 25. Bam. All right. Yeah, it's a gift. What can I say? All right, I can compare relative frequencies with known probabilities. This would be 9.7. Again, looking at this, so here's the frequency, previous ownership, Windows, Macintosh, and here's the total of people. Talking about computers preferences here. So 85%, total of 85 or 17.17 is the relative frequency. We have 60 people with Windows, 355 with Macs, a total of 500 people were in this sample. So we need to fill this in. So we need to find out what the relative frequency then of these is. So this is really, if you want to figure out, you want to check it, you can take the 17, well, we'll take the 5, we'll take this 85 here, and we'll divide it by 500, and that should be that relative frequency there. See if they're rounded or not. 85 divided by 500 is 0.17, so that worked out pretty slick. So let's go ahead and double check this 60 here. We'll clear that out. 60 divided by 500 is 0.12 would be the relative frequency of a Windows user. Ooh, Max won the big lotto here. So we have, again, just do this out of 500, just to see. So we have 355 divided by 500, and that is 0.71. You add those all up, and we'll just do that. 0.71 plus the 0.17 plus 0.12, and there's your 1.0, or 100%. All right. That's all we've got. Just make sure there's not another page here. I think that's it. All right, thanks for listening. Have a good day.